Hi gang, we are now on lesson 17, which is the second lesson for project 4. We are still looking at sequences and functions to solve crimes. So we've got 5 questions to go. Let's go ahead and get started. Question 1. Some liquid evidence was found at the scene of a crime. Detectives are performing several different tests on the substance. The amount of substance needed in ounces for each test is given by the sequence. 4, 2, 1, 1/2, etc. Is there a common difference or common ratio for the sequence? Also, is the sequence arithmetic or geometric? So, as you can see, to get from 4 to 2, we could subtract 2. Or we could multiply by 1/2. To get from 2 to 1, we have to subtract 1. So we know there's not a common difference, but we can multiply again by 1/2. And then to get to 1/2 from 1, we again multiply by 1/2. So we can tell that this is going to be a geometric sequence that has a common ratio versus an arithmetic sequence which would have a common difference. Okay. The next question, what is the explicit formula that represents this sequence? So when we're dealing with geometric sequences, we are going to have a sequence that will look like this. A to the n, a sub n is a sub 1, or our first term, times our common ratio to the n minus 1 power. Okay, so our first term, if we scroll back up real quick, we can see that our first term there was 4. So if we plug back in here, we'll find that a sub n equals 4, and our common ratio we decided was 1/2, because that's what we could multiply each term by to get to the next term, to the n minus 1 power. Okay, so it looks like our first option is going to be the one that works for us here. All right, so I'm just going to rewrite it here in order to answer this question. What is the domain of the function that represents the sequence? So again, our function was our sequence actually, a sub n is a sub 1 to the r, or times r to the n minus 1. A sub n equals 4 times 1/2 to the n minus 1. Okay, the deal here is that we are dealing with specific terms and terms. So I don't really have an a sub 1/2. That's not really a term. The only terms I can have are the first term, the second term, the third term. So my constraints here on my domain, or my n terms, are all natural numbers. All real numbers, if you recall, are negative numbers, they're fractions, they're rational, they're irrational. So it could be anything. And I can't have anything but whole numbers for my terms. That would be like having half a person or half a car, or half of anything where we need to deal in whole units. Okay? All right. The next problem. How many ounces of the substance will be used in the 10th test? Okay, well, here's where we get to just plug into our little formula here. We have a sub 10 equals a sub 1, which was 4, times 1/2 to the 10 minus 1 power. 4 times 1/2 to the 9th power. Okay, well, as many of you have seen me do, I'm going to go over here and just use the Google calculator. And let's just go to a new tab. And I'm going to say 4 times parentheses 1/2 to the 9th power. And I get 0.0078125. So I'll just go back to this screen. 0.0078125 ounces will be used in the 10th test. So that's hardly anything. Okay. And the final question here, explain how to get from one term to the next in the sequence. Okay. So when I have the explicit sequence, I don't necessarily need to move, or the explicit formula, I don't need to move from one term to the next. I can find any term, okay? I don't need to know my previous term when I'm dealing with that explicit sequence, because all I have to do is know the value of n. But if I don't have that explicit formula, I can look back and I can see that I was going 4, 2, 1, 1/2, etc. Okay? So to get from one term to the next, we multiply by 1/2. Okay, so that answers the first question. So then they say, well, now come up with a recursive formula for the nth term. And when we're dealing with a recursive formula, that means we need to know the previous term. So based on the information we just provided, we multiplied the previous term by 1/2. So that recursive formula is going to be a sub n equals 1, let's put it in parentheses, 1/2 and a sub, and we'll put this in parentheses 2, n minus 1. So this means that to get to the next term, a sub n, I have to look at the previous term and multiply it by 1/2. So if I want term 2, I have to look at term 1 and multiply it by 1/2. If I want term 3, I have to look at term 2 and multiply it by 1/2. If I want term 4, I need to multiply term 3 by 1/2. So that's the difference between the explicit and the recursive formulas. Explicit formula, you just need to know the term that you want, and you can get your answer based on n that you're looking for. Recursive formulas, you need to know the previous number to get the subsequent number. So they both have their place. I usually prefer the explicit formulas, but this is the recursive, and you can always tell if you're dealing with a recursive or an explicit formula, because recursive formulas always have an a sub n minus 1 in the formula. So hope that helps, and I will see you back here for lesson 18. Thanks.